Can you introduce Martin for us?
Okay, I wasn't expecting that. So, welcome everybody. Today we have our last session, last chapter 12, about writing your own custom extensions. Today Jan will be presenting because he actually wrote the chapter, and definitely from two of us, Jan has more experience in writing extensions from scratch. So, Jan, floor is yours.
Hey, thank you. Matheus, will allow me to share the screen, please, because it's not allowing me right now.
It was a Martin issue. Now it's your issue.
Yeah, we had this like on every single like session, like every time we forgot to give permissions.
Okay, now you can share.
Okay, can you see the book?
Yes, we can.
Okay, so custom extensions. Let's talk about custom extensions and why you would want to possibly do it, what it can do for you, how you can do it, how you can test it, and stuff like that. Writing custom extensions isn't exactly something that most Quarkus users need to do, but in some cases you might find that it will be useful for you. For example, if you're integrating some kind of framework into Quarkus and want to reuse it across multiple applications, then it's probably a good thing to have an extension to support that specific framework and add some goodies on top of that, just like the already existing Quarkus extensions do. If you create your own extension, you can host it. You can have it hosted in our GitHub organization maintained by the Quarkus team. That's called Quarkiverse. I guess we already talked about it a few times. Quarkiverse is a set of community developed extensions. If you decide to write an extension and host it there, we will give you some automation, testing, CI pipelines, and the simply Quarkus team will help you maintain that. Okay, so now we will look at a bit of a motivation why you might want to create a custom extension, because that's what how the chapter starts. Then we will have a look at the basic concepts, like what's a module, processor, recorder, build item, the basic structure, how to create an extension. Then I will show actually an extension in 12.3. It's quite a simple one that if you add it to an application, then that application will simply expose an extra REST endpoint, and at that REST endpoint, when it's called, it will return some basic metadata information about the application. So it's pretty simple. I will also show how to test an extension, because there's an internal testing framework for that. And yeah, if we have enough time, and then I can show some more examples from already existing Quarkus extensions to give you some more ideas what they can actually do. I have a few examples to show. So let's get to the motivation. So what can Quarkus extensions do? Probably the most important thing that they do is initializing some parts of the application at build time. We already talked about it many times that Quarkus has this build time initialization concept, where some parts of the application are initialized already at build time, and that through what we call bytecode generation. So things like reading the configuration files, scanning the application code for annotations and so on. That's all done in build time, and the result of this is baked into the resulting application in the form of generated bytecode that's highly optimized and is easy and is fast to execute. So when you actually start your application, we don't anymore do all that stuff like reading the configuration files and scanning the annotations. It's all just some simple bytecode that gets executed, and the resulting model that was built from this kind of information is built very quickly and put into the memory, and the application can start very fast. So this is like the most important things that that Quarkus extensions do. They calculate some kind of model of the application and record that model in first bytecode and put it into the resulting artifact of the application. We will see that in the example, because we will be calculating this metadata about the application and its dependencies. We will be calculating that at build time and storing it in the application. What else? An extension can add configuration values. Configuration properties are of two types: build time and runtime. Build time properties are those that are only read at build time and fixed at build time. Quarkus extensions can already use that information from these build time properties when building the application model, and that you can't act upon the values of these properties, and you can't override them at runtime when you are actually starting your application. They are only used during the build time. And then there are runtime properties. Those are those that you can override at runtime, so the build time processing doesn't actually act upon them. Yeah, what else to add here? Dependency injection, that's a very common use case for extensions. An extension can provide CDI beans, can scan the application to detect which classes should become CDI beans and register them at build time. This all happens at build time. At build time, it builds the whole CDI container model, called the whole list of CDI beans is detected at build time. It can and other stuff that extensions can do. Dev mode shutdown hooks, for example. Yeah, if you use dev mode, then some resources need to be cleaned up every time the application is restarted, and that's what the extensions do. They register shutdown hooks so that the cleanup can happen properly. An extension can add dev services. We've used these many times. And yeah, the extension can provide information about how to build the instances of dev services, which images should be used, when they should be started, when they should be stopped, and so on. So this is all handled by the respective extensions that own these dev services. Extensions can add cards and functionality into the dev UI. We already also use the dev UI quite a lot, so you saw these cards there where you can view the list of CDI beans, for example, or the GraphQL schema, and so on. Or, I don't know, gRPC console, where you can test your gRPC endpoint by executing all the operations and all of that. This is also done by extensions that can add new cards into the dev UI. Native mode extensions can provide some additional metadata that is necessary to be able to compile your application into native mode, because not everything is compilable into native mode by default. You might need to do some substitutions. If we have enough time, I will show some substitutions where the contents of some classes are replaced specifically when they are being compiled into native mode, just to make the compilation possible. Registering classes for reflection as well. Yeah, and an extension, if it knows that some specific classes are necessary to be registered for reflection because they are accessed reflectively at runtime, an extension can automatically register those classes for reflection. So the application developer then doesn't have to do that. Okay.
Okay, and if I may,
Yes.
before you move on, you basically, Jan said it between the lines that you have access to basically everything the user of your extension writes. So you have the whole class path available. You can like search for like implementations of some interfaces, add annotations, even like override some methods if you have use cases like that. So like you have a lot of power to basically change a lot the application you have in hand, and you are executing most of these during basically build time. So yeah, you can basically change the whole application if you like. This is why I want to say this is because like in Quarkus you can add any Java dependency, any Maven dependency that you pull from central to any application, and it will most likely work if you stick to jar. But if you want to get that additional benefits that Quarkus can provide, then you need to basically create that extension that will basically split the processing of the library to build time and runtime.
Okay, thank you. Now let's get to some basic structure of how to create an extension. So there's a few theoretical concepts that need to be explained, because build time runtime split. So I will try to very briefly explain the most basic concepts, just to be able to explain the basic stuff, because it's a very complicated subject that can take many weeks to really learn everything there, because there's a lot of theoretical stuff there. Modules. An extension typically consists of two Maven modules. One is the deployment module, and one is the runtime module. In the deployment module, there are classes. There is code that is only needed at build time, and this deployment module is not present in the final artifact in the final application. This is only the build time stuff. That's another feature of Quarkus, that all these libraries that are needed for the build are not part of the resulting application, are not present in the runtime class path, which makes applications leaner and smaller, faster to start. So in the deployment,
less TVs in production, that's important.
So we have deployment module, runtime module, and usually these two modules are wrapped in a single parent Maven module. And yeah, you can also have a third module, for example, with integration test. In the example that I will be showing, we actually have that, but we don't make use of integration test. We have unit tests only, I think. And now something about the build time processing concepts. So there are two or three important concepts: processor, recorder, and build item. A processor is like the basic unit of build time processing. It's a class that contains some logic that is executed during the build time. So each each extension has one or more processors, and a processor is a class, and that processor can contain methods. Those are called build steps. And these build steps are the actual logic that needs to be executed at build time. And build steps communicate with one another through things called build items. Those are special classes that are used to pass information between different build steps, even between build steps belonging to different extensions. We will see in a bit that, as an example, if what could be an example? If an application, if an extension wants to say that a specific annotation should be considered as a bean defining annotation, that means that all classes having this annotation should be turned into CDI beans. Then that extension will produce a build item called bean defining annotation build item. And this build item will tell the CDI extension named arc that it needs to scan the application for all instances of this of this bean defining annotation, and all classes that have this annotation should be should be transformed into CDI beans. So this is one example of how build items are used to for communication between build steps. And other things that build steps can do is injecting a recorder, and the recorder is a very special class that actually performs bytecode recording. So whenever a build step creates some kind of object that needs to be recorded and put into the resulting application, serialized into the resulting application, that build step will pass that object into a recorder. The recorder will actually take that object and transform it into generated bytecode so that this object can be recreated during runtime when you actually start your application. For as an example, that will be we will be showing in our I was showing that. For example, when a build step creates a model of, I don't know, the GraphQL schema, for example, or the set of REST endpoints and stuff like that that was just scanned from the application classes and turned into a set of objects, then these objects will be needed to be recorded so that they are accessible at runtime, and then the GraphQL schema can be applied when the application starts, or the REST endpoints can be registered when you're starting the application. There's a library called Gizmo that's used also for bytecode generation. That's another thing that processors can do. They can not just record bytecode, they can also generate bytecode using this tool, this library called Gizmo. That can be used for generating JVM bytecode that is highly optimized. And the main reason is to avoid the need for runtime reflection, basically, usually. Okay, so here's a bit about how the build items work together. There's this concept of extension. An extension contains one or more processors. Processors contain build steps here. Build steps can call recorders, and those recorders record objects created by the processors and create this thing called runtime object that will be put into the packaged artifact. and build steps produce build items. So that other build steps can consume those build items. So as I said, that's how the build steps of or also from different, possibly of different extent, from different extensions communicate with one another.
Do we also have runtime value in the example? I don't remember. Runtime value.
Yes. We create a runtime value with the string with the application metadata. We'll get to that very soon.
It would be also good to mention that. I will basically leave it to you when to mention.
Yeah, it will be in the example, so we'll get there very soon. Yeah. One last thing here that I wanted to mention is, that we used another important library that is used is called Jandex. Jandex is an annotation indexing tool, and that's the input that extensions get when building the application model. The Jandex index is basically information about all the classes, methods, and everything, and annotations in the application code. And from this Jandex index application, the extension actually scans the annotations and everything. That's important because we don't actually load at build time. We don't actually load the application classes using regular Java class loaders. That probably wouldn't work. It would be slow and cumbersome. Instead, we run Jandex on them on the compiled classes, and then use Jandex for the scanning instead of actually loading the classes and using reflection. Okay, how to create an extension. The Quarkus CLI, just like it can be used for creating a Quarkus application, it can also be used for creating an extension. Here we have an example, quick Quarkus create extension. Here you get the group ID, artifact ID, and the Quarkus version that should be used. Or you can also use the Maven plugin. And this will create, yes, as I said, it will create the two submodules, runtime and deployment. And it will also create an integration tests module with some default test will be also included in there. Okay. Here's a bit about how to extend the configuration model, but you know what? Let's just skip right to the code. Because I think it will be better to also already show the code. I think I've explained the most basic concepts here. So I will not be creating it from scratch. I'll just show the final extension as the reader will create throughout reading the book. It's called metadata extension. As I already said, it's something that at build time it collects information about the application, and by that I mean the name of the application, its version, and a set of dependencies. And when you actually add this extension to an application, it will expose that over an endpoint. I will start, and we actually added to inventory service, which is one of the applications from the car rental system. I will show you that in the POM of the inventory service, we have added this dependency on the org acme metadata extension. And that's how you actually then add that extension, just like adding any other extension. Just in this case, we provided also the version because the version isn't provided by the Quarkus BOM. When you start the application, we'll start it in dev mode. I don't remember where exactly it is.
You have it actually in the test that you have opened some other part because it was changed in the last section.
Metadata.
Slash
Oh,
metadata
yeah.
is another thing that then we change it in the last section. So it depends where exactly you are checked out in the book.
Slash, it's here in anyway here it's slash metadata. So I will show what happens when you call it. This application runs, hold on, sorry, it runs on NT83. So slash metadata. Oh no. Okay.
So,
So
because you are changing it with the configuration, so it will be some other path. Check application properties.
Oh, some other path. Okay, so this is the right one. Oh, okay, I will run it through JQ. Okay, so this is the output. So it returns a JSON document with three properties. One is the name, inventory service. One is the version taken from the POM, and one is a set of dependencies. So these are all the, I think, runtime dependencies that are present in the application. So here is we see inject API, smallride config, some logging stuff, all the runtime dependencies. And this is yeah, I will show where we actually calculate this stuff and how it gets from build time to runtime. So here we have the metadata extension. And let's have a look at the deployment module. We have this metadata extension processor that contains a build step. And this build step is the thing that computes the model, the JSON object at build time, and passes it through a recorder to create an HTTP handler that serves this endpoint. So, okay, this build step injects a few objects that are necessary for that. We inject a recorder to be able to record bytecode. We inject a build item called application info build item that comes from another extension, and it's from Quarkus core extension. It contains the name and version of the application. App model provider build item is another build item from the Quarkus core extension that provides the information about the dependencies of the application. And we also inject something that comes from this extension itself, and that's a configuration object. I will show that in a bit because that is how an extension can extend the configuration model. So here we build the resulting JSON stuff. Put the name there, put the version there, put an array of dependencies, and we take from the application model provider build item contains the information about the dependencies. So we get all the runtime dependencies from it and add it into the JSON object. Then we use the recorder to create a handler. I will show the recorder. We call recorder create handler with the string. We at this point we have built the whole JSON document that's here in the JSON toString, and we pass it to the recorder to create a handler. And this is the recorder. it takes a string and creates a new metadata handler, which is a class that implements an HTTP handler. And this handler of routing context is something that comes from the Vertex HTTP extension. And we provide an implementation what happens when this handler is executed. So we take into the routing context, we put a header into the response. We say that the content type of the response is application JSON, and put the data, the string as the body in the HTTP response.
Just Jan, can you just quickly show us where you are, because you jumped to runtime module, and like it's good to showcase like where exactly the jump happened. Because now
Okay, yeah, the processor is in the deployment module, so the processor will not be part of the resulting application, but but recorders are already in the runtime module, and this metadata handler is also in the runtime module, because this is something that will actually be needed at runtime. Okay.
And I see that you have two build steps actually in the processor. So how does Quarkus know like when to call each build step and in which order?
That is derived from the build items that are consumed and produced by each build step. That I mean that if one build step produces some type of build item and another build step consumes that type of build item, then the second build step needs to be executed after the first one. If two steps don't have any common build items, then the order between them isn't defined. But yeah, before actually executing the build steps, Quarkus scans them and what they produce and consume, and builds a graph of dependencies to be able to see how exactly in what order they should be executed. If you have a cycle in that graph, for example, one build step produces something, and build step A produces something and consumes something else, which build step B produces what the other one consumes and consumes what the other one produces, then you would have a cycle in the graph, and Quarkus would throw an exception because that's not possible to do. But generally, yeah, the Quarkus knows from the build items that they're how in what order the build steps need to be executed. Okay, and the last important thing that happens in the create route build step is that it creates a route build item, which is something that is consumed by the Vertex HTTP extension. It tells the Quarkus HTTP Vertex HTTP extension that it needs to register this handler that we created from the recorder, this HTTP handler, and expose it over this path. And the path is actually part of the configuration, which I will show right now. This defines where the endpoint will live, and that thing is configurable. We have this configuration interface that says that we have a configuration namespace Quarkus metadata, and inside the metadata we will have a property named path, which has a default value of /metadata, but an application can override this. If an application doesn't override it, then the value of the path where where we will be exposing the metadata will be slash metadata. But just like our our example did, you see here Quarkus metadata path. That's the inventory. That's the code of the inventory service. We have Quarkus metadata path overridden to something else, to some other path. But if we didn't have this here, then it would be exposed on slash metadata. So the processor knows, and yeah, an important thing. This is a configuration object that has a build time config phase. That means that this can be consumed at build time. So you can directly inject that into a processor, which we do here, which we inject an instance of this configuration object, and we can read the path that is configured and pass it into the route build item that is then passed to the Vertex HTTP extension, which takes care of registering this handler when the application starts.
And I just want to add that like that config build time means that you can consume it at build time, but it also means that you cannot override it at runtime, right?
Yes,
That's more
because if you tried to override this property at runtime, it wouldn't work, because obviously we already created this extension already created at build time. It already created the route build item with the specified path. So it's not, and this will be baked via generated bytecode already into the application. So it's not possible to change the path in this case during runtime. If your application tried to do that, we would get a warning. The warning will say that you're trying to override a build time property at runtime, and that this attempt is not valid and it will be ignored. Okay, so that's a very simple example how an extension works and how you can add configuration values. Now let's have a quick look at tests, maybe. Yes, so we have this test.
maybe before you will go to test, if you are still running the application in dev mode, maybe you can show the UI that you have like build steps there. Like you can see the actual like build steps, how they're executed in the dev UI.
Okay. Hold on, I don't know where my browser is. Let's skip to another workspace. Hold on. My mind. Move to workspace 3 here. Okay, so that's the dev UI, and that was, where was it? I don't remember exactly.
I think the metrics is
Here are build metrics that says that this gives you information about all the build steps that happened during the build. And here's the build. Here's the create route build step that we have in the extension. You see that it took 217 milliseconds.
and click that icon at the end of the line.
This one?
Yeah.
Okay, yeah, these are the dependencies between build steps. So yeah, here you see that this red one is our build step that produces the
can you zoom it a little bit? Can you zoom it?
Hopefully, hey, I'm clicking plus and it's actually getting smaller. How do I zoom on it? Ah, okay, this is a bit better. Okay, so the red one, oh man. Okay, this isn't nice. Let's try again.
This is the full Quarkus.
Okay, I'll rather not click anywhere. Okay, so this the red one. That's the build step that we have in the extension. It produces a route build item, and you see that that route build item is consumed by Vertex HTTP processor initialized router, and yeah, and that one creates produces some more items that are consumed by other things from the HTTP and some other extensions. Okay,
Yeah, thanks.
so okay, now let's have a look at testing quickly. So here, yeah, there's a testing framework for specifically for testing extensions. It's pretty easy. In this case, writing a test for this extension is easy. You create an instance of Quarkus unit test, which basically means that you are generating an application because you're testing an extension, but an extension by itself it can't be executed or anything. An extension has to be part of an application. So you need to create an application, a dummy application, in this case, extremely dummy application that contains your extension, which is what we do in this case. It is you create this Quarkus unit test. Under the hood, it creates a very thin dummy application that contains your extension. You can. This is the simplest case possible, but in some more complicated cases, you can add specific classes, of course, to the application to see how the extension will handle them. In this case, we don't have to customize anything. We just create a dummy application that contains the extension. And the test, what it does is, that's pretty straightforward. When you get the metadata endpoint, then we expect the status code of 200. We expect the content type of application JSON. We expect that the body will contain the name, version, and dependencies JSON objects. And for the dependencies, we just check that it's not an empty array. So pretty easy. You run the test. It should hopefully work.
Just one more thing before you move on, because you have that register extension annotation, which is not, like Quarkus extension, so you probably should show the full import.
This register extension is actually a JUnit thing. This registers a JUnit extension, that's not a JUnit extension, not a Quarkus extension. But this JUnit extension will take care of creating a Quarkus application with your extension included. And I think my test is failing because I have the application running, right?
Yeah.
At least I hope that's the reason.
So if it wasn't clear, this is like a normal JUnit unit test. It's nothing fancy, nothing like Quarkus like specific, except for that Quarkus unit test class, which is containing all the basically configuration of the application under the test.
Okay, and I'm still getting a failure. I'm not exactly sure why it's giving 404. That we don't override the
because you have the wrong path, yes. Because it should be some other path.
No, that we're here in the extension itself, not the application. And the extension itself is, and we don't override it. We have another test that actually shows how to override the configuration. So maybe let's try to run this one. Maybe I just haven't. Well done. I'll run it with Maven because running tests in my IDE directly has been proving not very reliable. See, now the tests are passing. That's somehow when I do it in my IDE directly, sometimes that's wrong. I have no idea why. But yeah, I ran the test with Maven and everything passed. So yeah, let's have a quick look. This is the super basic test that just doesn't override the configuration. This is a test that overrides in the that simulates an application that also overrides this configuration value and overrides the path to something, some other path. So the test is also adjusted to expect that the metadata will be on this specific path. Then we have a third test that's for dev mode. Well, it doesn't actually do anything. It's just showing that you can create a dev mode test that will start the application in dev mode, and then you can do things like here. You have this dev mode test instance, this object, and you can use that to control a lot of stuff about the running application in dev mode. You can add new resource files into it, add new source files, right? And you can check how your extension will react to changes in source files. Modify file, you see that you can modify a specific file, give it a function that transforms an original function from string to string. That the first string will be the original content of the file, the second string will be the new mutated content. So you can test how your extension will handle modified source files and so on. So testing dev mode is also easy. Okay, so that's how you create an extension and how you test it. What else? If now maybe I could show a little bit about if you guys are interested, I can show a bit of the generated bytecode maybe, because we have some time, hopefully. Just something very briefly. Okay, I will then have to switch to the application, to the inventory service. Just to give you some very basic idea what the generated code looks like. I'm now in the inventory service in the application. I will package it, new package, and when you do this, it generates the resulting application along with the bytecode that you can then look at. And yeah, let's have a look into target Quarkus app, Quarkus. And here you see two jar files, generated bytecode and transformed bytecode. In this case, let's have a look at the generated bytecode. I will just unzip this file. This jar contains all the generated classes that Quarkus generated at build time. There's quite a bunch of them, and these are all class files, right? So we don't have the source available. There is no source, but we can have a look through a decompiler, right? So this one. Let's have a look at So this is I unzipped the jar file. So now I'm looking into the contents of the unzipped jar file. So I will look at the class IO Quarkus deployment steps, and here we have this vertex. I will find vertex HTTP processor initialize router. This one. This one is the interesting one. At least I hope so. Yeah, we will here. This is a build step from the Vertex HTTP processor that, as I showed, this is actually the build step that consumed the route that we create in our extension. And here I'm looking at the decompiled class file because my IDE has a decompiler built in. And here you can find it's not exactly easy to read, obviously, because it's just decompiled bytecode. But here, if you look closely, you can find some interesting things. Like, for example, here you see that it registers an HTTP route with the path of /metrics. That's for the metrics extension. Here it registers a route for the GraphQL UI, but what we wanted here, this is what is interesting for us, is this route with the path of some other path, because that's what our extension added actually. So this stuff is executed at runtime. We don't need to scan the configuration again. You see that the configuration value is baked into this. Yeah, there's somewhere is also stored the actual string of the metadata that will be exposed. It's not shown here because it's somewhere under one of these proxy keys, somewhere stored. That I don't exactly know which one, but it's somewhere stored there, and yeah, it's retrieved here, and a new route is added for the HTTP on the HTTP server. For F, then also small rive health is here. For example, it creates a route for the health endpoint, liveness endpoint, and you see that this route will be handled by the smaller liveness handler and so on. So you see that this bytecode is already contains all the information highly optimized, that so that we don't need to scan the application again for anything. We just quickly execute this, and all the necessary handlers and routes will be created, or will be registered. Another
Yeah.
example. Mhm.
One question, because when I created a Quarkus application, I don't have a main method, but okay, at the final we will have. Can you share with us the main method?
Yeah, it is somewhere, but I'm not sure exactly where. It could be. I think it's.
It's just to show.
Yeah. I know.
Actually, I
But
don't think that it's here because it will be in Bootstrap, I believe.
I think it's in the Quarkus run jar, obviously, right? So if I have a look in the contents of the Quarkus run jar, there's a meta inf manifest nf file. Have a look at that.
Maybe you need to. I don't know, but maybe we need.
Main class IO Quarkus Bootstrap Runner Quarkus entry point. So yeah, so in one of these jars, I don't know from the top of my head.
There is a
That's the
Bootstrap jar in like Quarkus app.
So this will be the main class. I don't know where I exactly find it, but yeah,
Okay.
I can try to maybe look at the source of this class if I have a. Yeah, this is the. Now I have the source code project of Quarkus itself open, and this is the main class.
Great. It's a very common question.
Okay, maybe another example of the generated bytecode if you want. I have this one for GraphQL, for example. This build execution service. Okay, yeah, by the way, each class here corresponds to one build step, right? Just to be clear, this class is named Smart GraphQL Processor $build execution service something. So that means that it was generated from this build step named build execution service that lives in the Smart GraphQL processor. And this is an example of a build step that that holds the serialized GraphQL schema. The GraphQL schema is built at build time and then serialized into using this class. And here you see it, that this is the bytecode that instantiates a new instance of schema and fills it with the GraphQL operation types and operations. So it creates a type for car. See the what else? That the car has an ID of type big integer and so on. It's not exactly easy to read, right? But all the information is there. That the car has a license plate number. All the information that was scanned from the annotations and everything from the application is hidden here. All the necessary stuff that builds the actual schema object. Yes. So yeah, that's it. Or one more maybe. Or I could show a Hibernate generated class if you're interested. I may inventory model. That's a Hibernate proxy for the car class, because we have this car. If you remember, in the inventory service, we have this car and car class. It's a JPA entity. And what Quarkus does at build time is that it generates a Hibernate proxy. So that's a class car Hibernate proxy, blah, 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 that extends the original class. That's important. And it also implements Hibernate proxy. And what it does is that whenever you actually use cars in the application, you don't get an instance of this class directly. Instead, you get an instance of this Hibernate proxy, and it overrides all the methods of the original class. So, for example, set ID, when you call set ID, it just doesn't just set the value of the ID field in the class, but it also intercepts it and performs all the Hibernate magic to tell Hibernate that it might need to perform an SQL query to update the ID in the database. So that's how Hibernate works. This is all generated bytecode at build time. Okay. Any other questions or ideas what we could show? I can also show maybe substitutions.
Yeah, maybe one question to this. So, like, this is how Quarkus does it, but this proxy, I suppose, needs to be generated in Hibernate every time. So, in other frameworks, which we don't need to name, this needs to happen, like every time that you start the application. And that goes for like everything that the library needs to generate like this. And you need to do this on every, like start of the application.
I have not a question, but just to ask you to talk about the difference between the static init and the runtime init, because we talked about the configuration, the time, and runtime, but I think we need to talk about static init and runtime init.
Okay, yeah, this makes a difference only if you're using native mode. In JVM mode, there's no difference between static init and runtime init. In native mode, the difference is that recorder code that is declared as static init is already executed at build time and baked into the native like binary as like the result of it as it already created objects and everything, the heap objects from executing the code are stored in the native binary, whereas with runtime init, this code will only be executed at startup when you actually start that application in native mode. So some things cannot be done during static init. For example, binding to opening a socket for network socket, for example. You can't serialize an open socket into the binary, right? This is something that needs to happen at runtime. So the runtime is in it is for things that cannot be done at build time.
Thanks. Marceline, you had a question?
No, not today.
If we have a bit more time, I can show some more examples. For example, from the more GraphQL processor to give you some more ideas what extensions do.
Yeah, that would be nice.
Okay, so yeah, here is an example of I talked about that, the bean defining annotation. For example, when you use the GraphQL extension, we turn the GraphQL API annotation, which is Org Eclipse Microprofile GraphQL API. That's an annotation. We want all classes that have this annotation to be turned into CDI beans. So we turn this annotation into what we call bean defining annotation by the Smorai GraphQL processor producing a bean defining annotation build item that says that all classes having this GraphQL API annotation will be turned into CDI beans with the default scope, and the default scope, if not overridden, it will be singleton. What else? Yeah, registering native image resources. Yeah,
Maybe I will just add on this that this is showing like the other option how you can produce build items from build steps, because one thing is what we used in metadata extension to return it as a return value, or you can use this build producer, which has basically a dot produce method, which is doing exactly the same thing, but with this build producer you can actually produce more build items from a single build step.
Yes, if one single build step needs to produce more types of build items, then you need to do it this way. Yes. But in this case, we could also make the build step, instead of void, it could just return a bean defining annotation build item directly. That would also be equivalent. What else? Yeah, one interesting example is runtime initialized class build item, which instructs GraalVM, the native image tool, about classes that need to be initialized at runtime. Because by default, it attempts to initialize all classes at build time, but in some cases that's not possible. For example, if the class contains any instances of a random generator, in that case you cannot initialize that class at build time, because if you initialize a random generator, it will be initialized along with the random seed. The random seed would be created once and baked into the application. So each time you would start that application, then the random seed would be the same. And your application, if you use that random generator for cryptographic operations, it wouldn't be secure at all, because it would always produce the same numbers. So it would be completely unsafe. So creating random generators at build time is forbidden. So, for example, if we have this class GraphQL util ID generator that instantiates random number generators, so that's something that needs to be initialized also at runtime. And an extension does it by producing this runtime initialized class build item that instructs GraalVM that this class needs to be initialized at runtime, not at build time. Yeah, anything else interesting? Build execution service.
Maybe
Yeah, here is where we built the GraphQL schema. Actually, this is use the schema builder to generate a GraphQL schema from the index from the Jandex index. Create a schema object, and then that schema object is passed to a recorder here. That's the schema object is passed to the recorder create execution service that um, creates the GraphQL execution service. Is just the class that takes care of handling GraphQL requests, and it requires the schema to be able to construct that execution service. So yeah, that's it.
So
Anything
maybe one
else?
last thing before you will finish is like, okay, I get it. Like writing extension is pretty easy, just processor with a bunch of build steps, producing, consuming build items. But how I will actually find out what kind of build items I have like available, like what kind of build items I can produce to different extensions, like this bin defining annotation, like like is there like one list of like all these build items that I can search?
Yeah, I'm not sure. Is that in the documentation? I don't think
Okay,
so.
okay, I will answer my own question. Yes, there is.
Okay,
If you
okay, I
go
didn't even
inside,
know. Because
if you go
okay,
into
well,
files, there is like
my way to do it usually is, I just find the build item class and search for all implementations, and this gives you a whole bunch of build item implementations, and then I just basically try to locate by name whatever I think that I need. Usually they have Javadoc comments, so you can deduct what each build item type does. That's how I do it. But yeah, okay, I guess it's also in some official documentation too.
so we both send it to the chat with Matheus. There is a guide which is basically pulling out all this information from Javadocs, but it's searchable. So pretty nicely. And one pro tip: if you don't find a build item for your use case, don't be afraid to add a build item to different extension.
Open it here. Ah, that's it. Yeah, core. It's split by extensions, and it gives you a list of all the build items in those extensions for our Agro, Amazon Lambda, and so on. Yes. So this is useful if you're building an extension. Not exactly useful for building applications, but for building extensions. Okay.
Okay, thanks, Jan. Pretty good overview.
Yeah. Well, let's finish our Quarkus in Action book club. This is the final chapter. I think that Ian or Martin will talk about in the next week about Appendix A. Sorry. No, it's not. Thanks, Ian and Martin, for the book, uh, for your time contributing with the Quarkus Club community and the Quarkus Road community. Thanks, Mussolini, too, to stay here with us, learning a lot. I learned a lot. Uh, and thanks. Subscribe to the channel, left your like, and it's all. Thanks, guys.
One more
Marceline,
thing. One more
okay.
thing before we adjourn. Actually, the book will be available, like the full PDF, on Red Hat Developer only until January 16th, I believe. So if you still didn't, if you are watching this on YouTube and you still didn't download the book, then I like hurry up.
Okay. Any considerations? Jan, Martin, Mussolini, if you want, go ahead.
I'm good. I just want to thank you for the opportunity to do this. It was like very interesting exercise that took a lot of time.
Yes, it was
But
very
I'm
interesting.
actually pretty happy that we have this like video documented because I know that some people prefer video content. So now you don't need to read the book. Well, you can read the book. You have audio book if you want to listen, and now you can also watch the book. So
And also,
awesome.
if you don't want to get lost on the book, so you can watch the video to go through it smoothly.
Okay. And Jan, do you want to talk anymore?
Oh no, I guess I don't have anything to add. Get the book and get coding, everybody.
Okay.
And when if you create a Quarkus extension, let us know. Connect with the Quarkus team on our Zulip, and we can host your extension in the Quarkiverse and give you any kind of support that you need to develop your extension.
Great. And if anyone want to contribute with an extension, what is this? The first step. Where can you contribute with it? If I want to contribute with an extension, where I can go?
Well, if you already have some code for the extension ready, then you just uh, contact the Quarkus team on Zulip, and we can set up a repository for you and set up some basic things like CI testing and so on. And
Great.
you can get your own repository where you can put that extension and work on it there and
Great.
get support from the team.
Okay. Thanks a lot. And bye bye. The last bye bye.
And
The
this
last bye
was
bye.
this one,
Yes,
Bye.
the last bye
Bye
bye.
bye.
The last bye bye.